Hi everybody, Professor Rad here, and today we're going to talk about evaluating expressions. So let's start by defining what that means. To evaluate an algebraic expression means to substitute known values into their corresponding variables and then simplify the answer. So let's do an example where we're given a formula and then asked to evaluate it for a few different values. So example 1 says, suppose an object is projected upward off the edge of a cliff. Its distance d from the ground below the cliff at time t is given by this equation, where d is measured in feet and t in seconds. Evaluate this formula for t equals a half a second, 2 seconds, and 4 seconds, and then interpret your results. Okay, so I've done my first read through the paragraph, and now I'm going to highlight the information that's jumping out at me. So the first thing that jumped out at me actually was that we had this formula. So I'm going to highlight that formula because we're probably going to want to use that. And then I noticed that there were two variables given to us, the distance d and the time t. So we have distance d from the ground below. And then it also said d is measured in feet. And then we have at time t, and t is being measured in seconds. And then we're evaluating this formula for half a second, 2 seconds, and 4 seconds. Okay, so really what seems like it's going to be one problem is really three problems because we've got 3 different values for t. So I like to start out by writing the formula. So I'm going to write out this equation they gave us, that d is 30 plus 64t minus 16t squared. Now I'm going to evaluate it for the 0.5 seconds first. So when you evaluate an expression, you're going to go through this formula basically, and everywhere I see the variable t, I'm going to replace it with 0.5. So d is going to stay there because I don't know the value for d. Then we have 30 plus, and we have 64t. Now remember that when there's a number in front of a letter, it means multiplication. So I'm going to have 64 times this 0.5. And then I'm going to carry on, minus 16, and then this is times t squared. So I'm going to write in times 0.5 squared. Now, at this point in the semester, we've been working on our order of operations for tons of different types of numbers, and we're fairly comfortable with that. So our focus here is not on, the computation of things, but on making sure we're substituting into the equation properly and then inputting this into our calculator correctly. So I've got my calculator of choice for the day here, and I'm going to substitute in. So I've got my 30 plus 64 parentheses 0.5 minus 16 times parentheses 0.5 squared. And that gives me 58, it looks like. Yeah. So d equals 58. Now, when I have a formula, whenever they give me a variable, like in this case, they gave me the variables d and t, they're also usually going to indicate some units. So here, t was being measured in seconds because we had 0.5 seconds. And it says d is measured in feet. So d is going to be 58 feet. Now, it also says to interpret our results here. So in this formula, it looks like little experiments going on. It says an object is projected upward off the edge of a cliff. So we've got a little cliff here, and let's say we're throwing, I don't know, a baseball or something off the edge of the cliff. and then it falls down, right? What goes up eventually comes down. And its distance from the ground below at time t is given by this formula. So here's the ground below. So basically what this formula says, you throw the ball at time 0, and then it goes up for a little bit, and then it comes down and crashes into the land. So if I want to know how high the ball is, like, I don't know, a second after I throw it, right? So maybe this is 1 second later. This formula tells me how high it is above the ground. That's basically what's going on. So in this case, since our time was 0.5 seconds, we could say 0.5 seconds after the object is projected, it is 58 feet from the ground. Below the cliff. So that's going to be our interpretation. All right, so all of this was for time equaling half a second. Now we're going to repeat this for 2 seconds and then 4 seconds. So I'm going to rewrite my formula. D is equal to 30 plus 64t minus 16t squared. And this time, instead of replacing t with 0.5 seconds, I'm going to replace t with 2 seconds. So d equals 30 plus 64 times 2 minus 16 times 2 squared. So I'm putting that times there because when there's a number in front of a letter, it means multiplication. The other thing I chose to do a little differently this time when I substituted in was I didn't put parentheses around the number. I don't know why. I kind of like to do that when I have a decimal or a negative especially. I like to put parentheses around it. In this case, I just chose not to. So we have lots of different notations for multiplication, so you can choose to include those parentheses or not when you substitute in. I will mention, especially if you have negative numbers, you do want to include those parentheses, since we know that if you have something like 5 squared, negative and then 5 squared, or negative 5 squared, these mean different things. So when you're substituting in, you want it to look like this. So if you're worried that you might forget it when you need it, you could adopt the practice of always putting parentheses around the number when you substitute it in. If you feel like you're going to remember those parentheses when you need it, i.e. when you have a negative to a power, then you can be a little bit sloppier. It's up to you. I know for me, until I became really comfortable with math, I was got to put those parentheses all the time, which is why I probably still instinctively put them up here. But either way, we can just go ahead and figure out our result. So we have 30 plus 64 times 2 minus 16 times 2 squared, and that gives me 94. And again, D is for distance, so this is 94 feet. For our interpretation, this time we substituted 2 in for t. So I would say 2 seconds after the object is projected. It is 94 feet from the ground below the cliff. Okay. All right, so we have one more evaluation to do with the 4 seconds. So why don't you try that one on your own? So you can pause the video and work through it, and then unpause and I'll have my solution here and we can check. So I'll see you in a moment. Okay, let's see how we did. So I once again wrote out my formula, and then I replaced each of the t's with our value of 4. And then I calculated it and got 30 feet. So we're at the situation now where the ball's almost landed flat on the ground, right? We're 30 feet from the ground instead of here where we were like 94 feet, pretty high up. And then for my interpretation, I just changed up the way I phrased it a little bit this time. I said the object is 30 feet from the ground 4 seconds after it was projected off a cliff. But you could have just maintained the same sort of structure we started with and have said 4 seconds after the object is projected, it is 30 feet from the ground below the cliff. All right, so we have another Now You Try here with a totally different situation. This one is about the lifespan of butterflies based off of how big their wings are. Again, you can try to evaluate and interpret your results. In the next video, we're going to continue evaluating expressions, and this time we're going to be expressing our answers in a little bit of a different way. So I'm looking forward to seeing you then. In the meantime, I hope you have a wonderful day. Bye, everyone.